Oh, what is ANOVA? Analysis of Variance is what it stands for. Let's say you have 3 or more groups and you want to compare the averages between those groups and see if it matters or is statistically significant. If you don't know what that is, please check out my video on p-values. You need to know what p-values are. If you only have 2 groups, you'll want to check out my video on t-tests, unless you already know what a t-test is. Just do that. But if you have 3 or more groups, let's do an ANOVA. So here is the code. This here is a one-way ANOVA. There's also a two-way, group-wise, interactions and blocking to consider, but I'll do them in future videos. Firstly, let's pull in the tidyverse package, pull in some data called df. This is the teacher marks. So we've got 3 teachers and the marks, the end of year marks for each of their students for the same class. This is made up data, by the way. And we'll just do some exploratory analysis there. So we'll group by teacher and we'll use this summarize function to count and find the count to the number of students, that is, and find the average number of marks. So looking at this summary here, we have 47 students under teacher A, with the average end of year marks at 78.3. For teacher B, it was 49 at an average of 66.5, and 48 students with teacher C at 76.7. So we can see that teacher B is quite lower than the rest of them and teacher C is a little bit lower than C's, but we want to make sure it's enough of a difference to call it statistically significant. To do this, we need to make a model using this ANOVA function for analysis of variance model. So first we put the number-based variable, so what makes the averages first, tilde, so this is in the top left of your screen, and then the grouping factor here, teacher. And then we just tell it where the data comes from. Cool, so we'll make a model. So now I've got a model object and I'm just gonna summarize that model and we get this output here. We do see there is a statistically significant, so you see the 3 stars and also a very small, this is the p-value column. We see a very small number. If you don't know how to read that, please check out my video on scientific notation. There's a difference between teachers. But at this stage, we don't know which teacher is different to which. We just know that there's a difference. Okay, so to find those exact differences, to quantify those differences statistically, we do a test that's hilariously called the Tukey Honest Significant Differences test. Now I'm just going to call it Tukey. The function we need is Tukey HSD. Make sure that you're conscious of the capital letters because R is case sensitive, and I chuck the model in there. Cool, so we have Tukey, and then I'm just going to show that test by just printing this to the console straight up. So that's just me hitting Control Enter there, and we get this output. So with this output, we see under teacher, we have the combination here on the end, the difference of the statistical test, the lower and upper bounds, the 95% confidence intervals of those tests, and then the p-value for it. So we see here that this is essentially 0 and essentially 0 for combinations B to A and C to B, or vice versa. And then we see that there's actually a very large p-value that is well above 0.05. We would actually suggest that C and A have no evidence to suggest that they are different. We can see these differences here. The way to read this now, it's just one little annoying thing. Well, I find it personally annoying. Maybe you don't care. But comparing these differences, you go from right to left. So to look at the difference between teacher A to B, on average, you need to go down 11. To get from B to C, you need to go up. You need to add 10. To get from there. So it kind of looks like B might be in the middle, but it's actually not. So just be conscious of the combinations. All right, to get a cool graph, we can simply just chuck that Tukey object into the plot. And we have this down here, the 95 family-wise confidence level. So we have the combination on the left, and then those intervals that we had before here. So we can see that 0, the combination of C and A crosses 0, which means that when considering differences between those 2 teachers, you can't rule out 0. So therefore, you can't say that there's actually a statistically significant difference. Like B and A and C and B, that there are statistically significant differences. Hope this helps.